Okay, let us start now the ideas of a car traveling around, traveling around tracks in a round form banked at a given angle. So you're going to start with this angle this example when you don't have friction. How this we don't have friction, we are going to there. So car with no tendency to slip. If you hear the word no tendency to slip, it means that frictional force is going to be zero. As simple as that. Or some question they will tell you if the surface is smooth. That also means there is no frictional force. So if you don't tell me that surface is smooth, they will say no tendency to slip. That means frictional force is going to be zero, because if there's no tendency to slip, it means that frictional force won't reach its maximum. Hence, no friction force there. So around a bend of radius 500 newtons banked at an angle theta to the horizontal. If it's traveling at a constant speed of 70 meters per second, find the angular speed angle theta. If the car weighs this, find the reaction between the car and the rod. Start with that. Start by putting a simple sketch. The note here is there. No tendency to slip implies frictional force is zero, i.e. no friction between the tires and the surface. So let me start with a simple sketch. So I'm going to assume this is going to be my horizontal. Then that's that a bend is banked at an angle, we don't know which is theta. Then we are going to be having our curve. They are not giving us the weight yet. Okay, so we just consider this to be our, okay. So now, they're telling us if the car weighs this, means that now we can put our weight there as 490 newtons. We are going to be having reaction there. That's our reaction. Then of course, as this car is moving, it's going to be having a certain radius from the center, because as it's moving around that tree, it's going to be forming a circular path. So they're telling us that the radius is 500. So from here up to that car, we have 500 root 3 meters. So that's the radius it's going to be forming as it's moving. We don't have anything like friction, so the diagram is done. I think you can see. Don't have anything like friction. So even here they can tell you motor speed. As simple as that. Whenever they tell you motor speed, this is the case. No friction. As simple as that. So what happens? They want us first of all to get the angular speed. So A, or we first resolve before we start doing everything. Okay, that's first resolve. This one, you see now, this angle is going to be, if I draw this like this, is going to be my horizontal. This is going to be the angle theta. This is going to be my reaction here. I think you can see, if I draw a horizontal, line part to the horizontal, this is going to be theta. And because this is always perpendicular to the surface, it implies that this is going to be 90 minus theta. Remember, this is going this side, which implies if this is 90 minus theta, then this is going to be theta. Basing on this idea, this vertical and that horizontal, so that's going to be theta. So now, if I'm focused on that, and then I bring it out that in this form, that's now my reaction. That's my reaction. And then this angle here, it's going to be theta. Even if you treat it as 90 minus theta, the answers are going to be the same. Okay, so this is an adjacent, so this is going to be R, and adjacent cos theta, as I told you, as I showed you in our first lessons. So then this is going to be, you see it's going to be opposite. Because this is moving like this, will go like this, then comes. So this one, the opposite, we are going to put it this side, so this is going to be R sine theta. Sine goes with opposite, then adjacent goes with cos. You see this is adjacent. So after that, the rest are going to be is for us. So start with, but now here the idea is don't try to resolve this because here we only want vertical forces and horizontal forces. So don't try to resolve this into forces perpendicular to the plane and then along the plane. No, this force is fully vertical. So we only want vertical forces and horizontal forces. That's why now these ones which are perpendicular to the plane, I resolve them into vertical and horizontal forces in this case. So don't try to resolve this. We want it to be vertical. Here we don't want forces along the plane. No, we want forces which are vertical and horizontal. So any force which is along the plane or perpendicular to the plane which is inclined, you try to make it vertical by resolving them. That's why I'm resolving these ones with ease. Okay. So now part A, they want me to get angular velocity, angular speed. And that if I have my velocity, do I have the velocity? Yes. My v is always equal in the radius, then times the angular speed omega. So I have this, I want this, I have this, I have this. So this one, the velocity, from here the velocity is 70 equal to the radius, which is 500 root 3, then times omega. So that my omega is going to be, this 0 will cancel, I'm going to be having 7 over 50 root 3 rad per second, and that will be done with ease. Angle theta, so how am I going to get angle theta? How am I going to get angle theta? That is called, so I'm going to resolve vertically because I'm seeing I'm going to be having cos and I'm going to be having sine because these are the only forces we have. So I'm going to resolve vertically, then I resolve horizontally, then I combine those two equations there. Okay, so let me start with resolving horizontally in this order. This is our part B. So resolving horizontally in that direction. So in that direction we have r sine theta is equal to 2. It's the only force in horizontal. We say any horizontal force should be equal to the centripetal force, the resultant component of our horizontal. I mean all horizontal components should be equal to the centripetal force that is keeping that particle in a circular path. So that's why this is the only component we have horizontally, so it's going to be equal to the centripetal force mvr, I mean v squared over r. So I call this equation 1. Then I resolve vertically. To resolve vertically, we have only r cos theta equaling to mv. Before I give this, because I never had this. So meaning, whether this was supposed to come in part B, but I just see. So this was supposed to come in part C. So before that, this is going to be now B. So that's the case. So that's what I have as MD. This is equaling to, now let me call this equation 2. You see, I can eliminate R, then I have this, which is going to give me tan. This will cancel. I have this, I have this, I have B. So we say 1 divided by 2 shall be having now R sine theta equaling to M V squared over R. We are dividing this with R cos theta, then we divide it with also md. I think we see this will vanish. This will give us tan theta. So we have tan theta equaling 2. I think we see this one is going to vanish. So I'll be having v squared over this divided by this, we get r and d, which you can easily simplify to. So our tan theta is going to be our v, which is 70 now squared, times the radius, which is 500 root 3 now times b 9.8. And so our tan theta is going to be, this is going to give me 4,900 over, this is going to give me 500 sorry. 500 times 9.8. It's giving me 900 root 3. See this one and this one there. That's what I say. I have 1 over root 3, and from there, my theta is going to be 30 degrees. This is a special angle. See? So I have this now. That was my part B. Then part C, if the weight of, if the car weighs that, where should I do my part C? Okay, let me do here my part C. If the car weighs, so remember our weight, or is our MD, is equal to the weight. So our MD here now is equal to 490. So now we can use N, but the best one is this. So from 2, depends on now my R cos theta equal to ME. I have now R cos 30. Notice this is 30 from here equal to ME, which is 490. Now some people are funny. Someone wanted to transfer this with this. Some people I don't know. So this is these are degrees. Anyway, so R times this is 45 root 3 over 2 equal to 490, which will cross multiply. From there, our R will be. We multiply that, we get 1960 over root 3 newtons. That's our reaction there. And so that's the answer we shall be with basically. And then life goes on. The number is done. So that's how we handle that. This is now the case we saw when the car is moving at a moderate speed, no friction. Everything is direct, but the idea is on this how we get these angles here. Don't try to resolve this into vertical and the forces alone, because we need vertical forces. That's why this one needs vertical and horizontal. Simple. That's it. I wish you well.